Today's lesson is lesson 85, solving problems using the Pythagorean theorem. You already know the Pythagorean theorem. This is nothing new for you. A squared plus b squared equals c squared is the Pythagorean theorem. Most important thing to remember is that it only works with your right triangles. Remember, your right triangle is always going to have that symbol of perpendicular between two of the legs. In our right triangle, we have two legs and we have the hypotenuse. You must be able to identify which one is the hypotenuse. Most important thing in working the Pythagorean theorem is making sure you put the right numbers where they belong. So we have to identify this right angle, and opposite that right angle, that is the hypotenuse. The legs are the things that make up the right triangle. So if you think of it like that, as the right triangle being made up of the legs, and then the hypotenuse is always opposite that right angle, you'll be able to apply the Pythagorean theorem better. Think of the Pythagorean theorem as leg squared plus leg squared equals hypotenuse squared. Doesn't matter which one you choose to go first, as long as they are the legs of the triangle. In these four problems, we're going to find the missing side using the Pythagorean theorem, calculating the missing side of a right triangle. So here we go. Here I have a leg, here I have another leg, and opposite my right angle is the letter W. That's my hypotenuse. So as I'm applying the Pythagorean theorem, it looks like this: 16 squared plus 12 squared equals W squared. Remembering that the hypotenuse is always the one on the other side of the equal sign. Now with 16 squared, I don't know, let's figure it out. 16 times 16 is 36, 9, 256. 16 times 16 is 256, plus 12 times 12 is 144, and that's going to equal W to the second power. I then add those two things together. It's a 0, 0. That becomes 400, which equals W squared. To undo the squaring operation, remember we take the square root. So from here I take the square root of this side and I take the square root of this side, and I get W is equal to 2 times 2 is 4. There's 2 zeros, so my answer is 20. W equals 20. 20 times 20 is 400. Let's look at the second example. This time I'm looking for one of the legs. The leg is identified with the variable t. I know that 5 is my hypotenuse because opposite my right angle there's that number 5. So applying the Pythagorean theorem, I say leg squared, which I'll identify as t, plus 3 squared equals 5 squared. T squared, I leave that alone. I don't know what it is. 3 squared is 9 equals 5 squared, which is 25. From there I subtract 9 from both sides of the equal sign, solving this equation, and I get t squared equals 16. 25 minus 9 is 16. Here, undoing the squaring operation with the square root, I get t is then equal to 4. T is equal to 4. This we'll talk about in a little bit. This is going to be one of your best friends once you learn the 3, 4, 5 right triangle. We'll talk about the multiples of that in just a second. Let's move over to the next example. Pretty big numbers, but please don't be intimidated. You know how to do the math. All you have to do is apply the theorem. Here we have 32 squared plus k squared equals 40 squared. Again, 32 times 32, let's do the math. One, 0, 2, 4 plus k squared equals 40 times 40, 4 times 4 is 16 with 2 zeros. I then subtract to get k squared equals, I hope you're doing this with me, 576. From there, I undo the squaring operation by taking the square root. I take the square root of 576, and the answer should be 24. Take the square root of this, take the square root of this, and k is equal to 24. For those of you who don't know how to find the square root of this, you play around with this number here. We know that 32 times 32 is this big 1024, 1024. So we know it's going to be a number smaller than 32. So what you do is try numbers like something that you know. 25 times 25, I know right off the top of my head, is 625. So it's got to be a number smaller than 25. So next you try 24. And 24 times 24 will yield you the results 576. So you got to play around with it, and the more you do it, the better you get. Pretty soon you'll be able to use a calculator, and all you'll have to do is use the button on the calculator, hit the square root button, and out pops your answer. But right now we're not going to get comfortable with those calculators. Look at the last example here using the Pythagorean theorem. I have an isosceles right triangle this time. Isosceles because two sides are equal. Opposite my right angle sits the variable m. I apply the Pythagorean theorem. 10 squared plus 10 squared equals m squared. 10 squared is 100. 10 squared is 100. That equals m squared. 100 plus 100 is 200, which equals m squared. Undoing the squaring operation, I take the square root. And here I have the square root of 200, which equals m. Got to make sure I simplify any square root that can be simplified. Remembering how to do that, it's the square root of 100 times the square root of 2, which is then 10 square root of 2. M equals 10 times the square root of 2. Next, we're going to talk about